Hey guys, and welcome to Chem Squad Chemistry. This is Mr. Mullins again today. We are going to be covering the ideal gas law, which is known as PV equals nRT. This is Unit 11, and we are going to be working directly out of our unit book, which is going to be on page 5. So if you could go ahead and turn there, we're going to have a few notes to take, and then we'll be there. So the ideal gas law is something that you need to keep separate from the combined gas law. The word ideal means under perfect situations where the pressure's not changing, the volume's not changing, and the temperature's not changing. Everything is going to remain the same. And we just want to know how these gases are going to respond at those specific parameters. So ideal gases typically exist at STP, remember standard temperature and pressure, but not always. They can be at all different types of pressure. So taking a look at the formula, we recognize some of the variables where P is going to be the pressure. And the pressure in this situation can be measured with only two things, either atmospheres or kilopascals. If they're given to you in millimeters mercury, you're going to have to convert it to one of these, and we'll see why in just a few minutes. It has to do with the R constant. The pressure is always going to determine what R constant you use. We see the V. We know that V is volume, and volume needs to be measured in liters. Again, if it's given to you in something else like centimeters or kiloliters or something like that, you've got to convert. The N is a new one, but it stands for moles, which you guys know. If it's given to you in grams, you got to convert to moles. We'll come back to R. T stands for temperature. And again, since we're talking about gases, it must be measured in Kelvin. Remember that Kelvin is Celsius plus 273. R is going to take a little bit longer to explain. R is considered to be the gas constant. Remember, constants are always the same. There are actually two gas constants that exist, and the reason for that is because of the pressure. If you would, let's go back and talk. You probably saw this formula back at the beginning of the year when we were talking about equations and the difference between variables and units. We know that the P, the V, the N, the R, and the T are all variables in this situation, but we can also use them to manipulate the units. So I'm going to need you to be able to solve for each one of these variables, especially R. R is going to teach you a lot about the formula. So let's go ahead and solve the formula for R. If we have PV is equal to nRT, and I want to get R alone, I'm going to have to divide both sides by N and T. Divide by N and T. You can see on this side they're going to cancel out, and we are left with PV over NT is equal to R. From this, we can determine the units for R. We know that pressure has units of atmospheres. We know that volume has units of liters. We know that moles has N has units of moles. And we know that T has units of Kelvin. So we can see R actually has some pretty complex units, which is atmospheres times liters divided by moles times Kelvin. Now you may be wondering, why is it that we have atmospheres here and not kPa? And that's going to lead us to having two different R constants. If we wanted to write it with kPa, it would look very similar, except the numbers will be a little different. The units will be the exact same. So you can see there are two R constants, and they have two different numbers that go along with them that you're going to have to memorize. So let's get to memorizing these R constants. So as I said before, there are going to be two R constants, and it's completely based off of the pressure. If someone gives you a problem that has atmospheres in it, you're going to need to use the R constant that is associated with atmosphere, and that would be 0.821 atmospheres times liters divided by moles times Kelvin. We can see that that has atmospheres in the units, so that's why we can use that number. If you were to run into a problem that has kPa, there's a different R constant, because we know that 1 atmosphere is not the same as 1 kPa, so it would look just a little bit different. So we see these are both of the R constants, and you need to have them memorized so that you can use them in the formula. R will never be given to you. You're going to have to know which one to use. If the problem is talking about kPa, we're going to use this bottom R constant. If the problem is talking about atmospheres, we're going to use the top one. If it doesn't specify, you can use whichever one you'd like. It just depends on what your pressure is, and we'll see that in some examples. So on page 5, we're going to go ahead and try a few examples of these. If you could turn to page 5, we're going to be doing number 1. So number 1 says, what pressure is exerted by 0.622 moles of a gas combined in a 9.22 liter container at a temperature of 16 degrees Celsius? So they're giving us lots of things. As soon as you see that it's talking about gases, you know that there are 3 formulas to use. You can use the combined gas law, you can use the ideal gas law, or you can use Dalton's law of partial pressures. The question is, which one do you want to use? Because this one's talking about moles, it is our hint that we are going to have to use the ideal gas law because it is the only formula that has moles in it there at N. So that's the little trick I use. So we know that since there are 4 variables here, we are going to have to know 4 numbers. So they're going to all have 5 variables, we're going to have to know 4 numbers. So 4 of them are going to be given to us. It says what pressure is exerted by 0.622 moles, so we know that's N, 0.622 moles. Of a gas contained in 9.22 liters, so we know that our volume is our liters there, at a temperature of 16 degrees Celsius. So we notice that that's in Celsius. You're going to have to make sure you change that to Kelvin by adding 273. So our real number would be 289 Kelvin. Now, why is it important that we're using Kelvin? It actually comes back to this R constant. The R constant has units of Kelvin, so we need to be using units of Kelvin. Here in this problem, we're looking for pressure, so it doesn't specify what units we need to use. So I'm going to be using the atmosphere's R constant. If you remember, the R constant for atmosphere is 0.0821 atm multiplied by liters divided by moles times Kelvin. So that's the R constant we're going to use. I know it takes a little bit of effort to write down those units, but don't get lazy here at the end of the year. So you can see all we're looking for is P. I encourage you, before you start plugging numbers in, go ahead and rearrange your equation to solve for P. Just a little simple algebra will save you a lot of time. We want to get P all by itself by dividing by V. So we're going to have P is equal to nRT divided by V. Now all we have to do is plug our numbers in. So we've got N, which is 0.622 moles, multiplied by R, which is 0.0821 atmospheres times liters divided by moles times Kelvin. And lastly, we've got our T, which is 289 Kelvin. And on the bottom, that's going to be divided by our volume, which is 9.22 liters. Now, it's important here to see what happens to our units. We can see that there's a mole right here and a mole here that's going to cancel. A liter and a liter is going to cancel. A Kelvin and a Kelvin is going to cancel. And oh, what are we left with? Atmospheres. That's why it's important to choose the correct R constant. They're asking for atmospheres in some situations, so you would have to choose this R constant. So after you type this into your calculator using 3 sig figs, because every number here except this one has 3, it has 4, our answer would be 1.60 atmospheres is P. So pretty simple. We just took some numbers, we plugged it into a formula, and we solved for the pressure. This would be the ideal gas law. Let's go ahead and practice number 2 together. Number 2 says, how many moles of a gas occupy 486 centimeter cube flask at 11 degrees Celsius and 66.7 kPa of pressure? So as soon as you saw the word moles and gas, we should be thinking PV equals nRT. And immediately they're asking us for moles, so go ahead and solve your formula for moles, which is going to be PV divided by RT is equal to N. Since we're using this, let's go ahead and figure out what all of our variables are going to be. We know that N is what we're looking for. In the problem, they told us that the pressure was 66.7 kPa. Since our pressure is in kPa, our R constant's also going to have to be in kPa, so it's one that we have memorized. It's a little different than the last one. The last one was in atmospheres. They gave us a volume, which is a strange looking volume, 486 centimeters cubed. And they also gave us a temperature of 11 degrees Celsius. I'm going to assume you are pretty good at calculating that to Kelvin, so I'm just going to go ahead and write that in Kelvin. I just added 273. So we run into a couple issues here. Hopefully you notice some things, that our volume is in centimeters cubed and our R constant has it in liters, which means we need to convert this into liters before we can do anything. Remember the conversion factor, 1 centimeter cubed is equal to 1 milliliter. Then once we get to milliliters, we can use King Henry died by drinking chocolate milk to go to liters. So we want to get rid of centimeters cubed. We're going to milliliters. Then we want to get rid of milliliters and go to liters. 1 and 1. 1 liter is 1,000 milliliters. And once you type this in, you're going to get 0.486 liters. So the first thing you always want to do is make sure your numbers are going to have the same units so that they will be able to cancel out. Remember, volume is going to be in liters every time. So now we've gotten to the point of where we just need to type some things into our calculator. We've got our pressure, which is 66.7 kPa. That's going to be multiplied by our volume, which we just discovered is 4.86 liters. And we're going to divide that by our R constant, which is 8.314 liters times kPa, divided by moles times Kelvin. And we're going to multiply that by our temperature in Kelvin. So there we go. Again, our Kelvins are going to cancel. It looks like our kPas are going to cancel. Our liters are going to cancel, and since this is in the denominator comes to the top, so we are left with moles, which is exactly what we were looking for, the old elusive mole. So in your calculator, all you have to do now is 66.7 times 0.486 divided by those numbers on the bottom. Remember, we have 3 sig figs, so you should have gotten the answer 137 moles is equal to N. So again, this is just some simple math that we're plugging into our calculator. The biggest thing that I want you to make sure you're doing is you are making sure your units are going to cancel. If you would go ahead now and try number 3 on your own, I will give you the answer to it here in just a few minutes. Go ahead and try that on your own, then we'll work it out. So pause the video now. Alright, so now that you have finished number 3 on your own, let's do it together. It says, what volume is occupied by... let me go ahead and write this down as I'm talking about PV equals nRT. Is occupied by 0.684 moles, so tell us the moles, of a gas at 99.1 kPa, of a pressure, a temperature of 9 degrees Celsius, so they gave us 9 degrees Celsius. We got to convert that to Kelvin, which is going to be 282 Kelvin. Mark that out. And they want us to find the volume. So we know that we're using PV is equal to nRT. We want to solve for volume, so we're going to get V is equal to nRT divided by P. So now we just need to plug some things in. In this situation, we don't know R yet. We have to use our pressure to figure that out. We see the pressure's in kPa, so that means we're going to be using our kPa R constant. Alright, so let's go ahead and plug these numbers in. We got 0.684 moles multiplied by that R, 8.314. Get a little sloppy there. And 282 Kelvin, just plugging it into this formula up here. And then our pressure was 99.1 kPa. Let's see if all of our units cancel, see what we're left with. We got moles and moles, Kelvin and Kelvin, kPa and kPa. We're left with liters, which is a measurement of volume. That's what we were looking for. So when you type this in your calculator, it looks like we have 3 sig figs, so that's going to be 16.2 liters. If you want to pause the video now, go ahead and try 4 and 5. I'll give you the answers to those so that you can make sure you're doing it correct. So pause the video now, try 4 and 5, and I'll write the answers up in just a few seconds. Alright, so hopefully you've worked out 4 on your own. Number 4 was a problem. We had 8,570 Kelvin was the answer. You should have been solving for T. And for number 5, the answer is 0.028 atmospheres, and you should have been solving for P. If you solved for kPa, you used the kPa constant, I believe the answer was 2.9. I think it was pretty close to that. All right, guys, that's going to be it for today. We have now learned all of Unit 11, so prepare for your quiz tomorrow if you'll be having one. You've made it through everything that you need to know in chemistry, except for nuclear chemistry, so the end is in sight. Hope you have a great day. Thank you.